Hello, it's Steve with a greenish screen. It's kind of more teal. Ooh. I kind of like the weird fuzz, so we're keeping it. Anyway, let's get to it. I like fighting games. Yes, I like the art and the action and the music. Here's some recommendations, by the way. But on a deeper level, my enjoyment of the genre stems from a more vibes based, pseudo philosophical space that I have yet to fully articulate. It has something to do with the way it naturally slots into hyperfixation and skill improvement. Four words that'll probably end up going on my tombstone someday. So it goes without saying that in this day and age, my favorite hyperfixation community is FGC YouTube. Can I do this? Can I do these? Can I do one of those? Here's a tier list. On one hand, I think it's pretty funny. On the other, I think putting actual humans on a tier list is a bit dehumanizing. But I guess my internetiness won out this time and it's staying in the video. Anywho, in more than one video in this space, though I believe most recently it was mentioned by Sajam, online matches in fighting games, specifically ranked, are treated with specifically the word rep, or reps, which is somehow both a metaphor and not. I believe it's used in the sense that it's a metaphor for working out, but also it's really technically not a metaphor at all, because it is literally repetitions of playing the game. Well, this video is a rep. I'm going to be doing some weird stuff here, as you can already tell, and it's going to be covering my latest rep of game dev. There will be more. Take it as it is. So I made a fighting game. I wish. No, I made 80% of a fighting game engine in Godot and 0.01% of a finished character. But let's talk about it. So here it is. As you can see, we have some pretty sophisticated fighting game mechanics, combos, juggle state, cancels, dash cancels of all things, jank-ass air dashing, was working at one point, but you'll just have to take my word for that. Let's talk about how this works under the hood. But here's the twist. I'm not going to be talking about combos, juggle states, cancels of any kind in this video. No. I'm going to be focusing on the actual deepest nuts and bolts of how this engine works. So, data structures, main loop stuff. I'll cover what I like about it and what I'm likely to change next time my brain decides to hyper-focus on fighting games. Alright, overview. We're gonna... Don't trust me, the frog metaphor will become a little bit more apparent pretty soon here. So in broad strokes, a 2D sprite-based fighting game is just a complicated animation system. Or really, two complicated animation systems interacting with each other. Like that. Doing one of these. In the pattern this project went with, there are two animation controllers, each of which reacts to one, an input signal, and B, the mechanics of the game itself, like hitboxes and hurtboxes. In the structure of our game here, each frame is conceptualized as a little data packet with information about where each sprite is on the sprite atlas and a bunch of frame-sensitive game data like hitboxes and hurtboxes. Don't worry about this screen, we'll talk about this later. So let's go through this like we're dissecting a frog, but inside out, like we're dissecting a frog bones first, by which I mean we're starting with the bones. The heartbeat of the bones of the engine, I'm glad I went with this metaphor, is here in Frame Manager, where I translate the process tick signal into a static 60 Hz tick. I know I could set the Godot physics process to 60 Hz, but I wanted more control over these ticks later down the line for things like rollback, so this is what I went with. Basically, it compresses this tick signal into a 60 Hz heartbeat. So each frame we run this block of code that determines the execution order of the game logic. The logic here is split a little sloppily. In retrospect, I could either add a more complex scheduling system to make these events make more sense, or I could have just nixed the events altogether and just use a strictly controlled execution order. The reason this ended up this messy was that I chose halfway through the development to split some of the logic out of the character controller into these managers. And then I didn't fully commit to the bit and just kind of did both. So now there's giant functions on the character controller and these out-of-context static functions just sitting out in the ether. Whatever. There's also fun naming conventions like Pushback Manager, which is obviously different than Push Manager, and obviously different than the Physics Manager. These all make plenty of sense. I'm sure this code base would be totally possible to pick up if you weren't just the person who made it. Overall, ugly and hard to maintain. But I also don't plan on adding many more mechanics, so I can see a world where I just let it calcify and live with it. So each one of these ticks advances a ring buffer associated with each character, as well as one shared buffer that holds just hit stop for some reason. A ring buffer, for those unfamiliar with the concept, is just an array of values of a set size where the next index loops around to the front when it reaches the end. This is what we use to store the historical frame information, like events, animation states, position, velocity, whatever. I just kind of let myself add columns as it went here, but ultimately the goal would be to use some sort of GD extension code with a similar interface that would allow me to have greater control over the actual shape and storage strategies of the data. But I also decided that I would just cross that bridge only if it starts causing issues, and it hasn't yet. So for now, it remains a bunch of packed arrays. Alright, moving on to the guts of the frog. Yummy, yummy frog guts. I had recently discussed the separation between game data and game configuration. In this project, that distinction can be drawn between the buffers that we just talked about and what I call the character document or character package. This character package is just basically a collection of files in a folder, all tied together by a naming convention and location. The actual character data is stored in these JSON files, which are converted to the character models at runtime and dictate all sorts of character-specific stuff. These character models hold some basic info, name, health, etc., but are mainly comprised of a giant list of animations, each of which has a set of frames. These frame objects actually hold most of the useful, gameplay information, like damage and things. So that way, if you need to vary, the damage on hit, let's say, an attack does 60 damage during the first couple active frames, and then it drops off to, 40 or something, so you have a nice spiky hard hit and a soft hit zone sort of thing. You can do that way. And there's all sorts of other things like that in fighting games that are very frame-specific data. The term frame data you might be aware of. There's more to it than just numbers. I mean, there is and there isn't more to it than just numbers, but that's programming, I guess. Each frame, a character's previous state is read from the buffer, whatever we end up storing in that buffer, and combined with inputs and the character document determines its next state. Really, most frames play out the same regardless of player input, as the fighting games are based around committal animations, basically prioritizing the simulation of actions over the intention of the player. That's why we have concept like cancels, where it's noteworthy that you can cancel one animation into another versus it just being expected that as soon as you push forward or back, you start moving, that sort of thing. That was confusing. That was a confusing example, but you know what I mean. Think about any video you might have seen about Dark Souls and how its animations feels weighty and consequence heavy. Fighting games are pretty much the same. In fact, you could draw a pretty straight line from Dark Souls to Castlevania to early fighting games, I believe. I actually think this is what leads fighting games, and Dark Souls for that matter, to being such a satisfying skill to learn. Actually, to get a little off topic here, this is also the same experiential thing, I believe, that causes racing games to be so fun. It's kind of like the satisfaction that comes with wrangling a never fully in control system. Okay, there's the guts. Finally, the skin, which is for some reason the innermost layer of the frog. This is going to be the strangest, most shameful, and yet most fascinating part of this project, was the character editor. Yes, I used an LLM to vibe code the animation editor for this project, and what's worse, I used a cloud-based service for it. I'm horrible. I'll never live it down. I'm not going to mention which service I used, but for those interested in my take on the LLM-ness of it all, here we go. There's some that would say any level of AI involvement in a creative project automatically invalidates the whole thing. I am deeply sympathetic to this view, but I believe it's more complicated than simple black-white. For instance, I love using AI-based stem separation in music whenever I got the chance. I think that's super awesome and fun. I'm currently hoping for LLMs to get more efficient in the future. They're already showing this trend of being able to run kind of usefully on small or local machines. This is what I ultimately want. We're not going to know what the morally correct stance it was until the far future, if ever. Really, on a personal level, I just hate paying subscriptions, and these tech bros gross me out. So I'm currently looking at ways into messing with LLMs more locally and having mixed results, but... Anyway, hopefully that clarifies my stance here, or muddies it enough that maybe nobody cares. Long story short, I've been grappling with how or if I want to involve LLMs in my game dev. I think going forward, I've landed on a useful paradigm, which is tooling. The way I put it is that a tooling focused game development is really based around building systems that allow you to build the game rather than trying to build a game directly from code, if that makes sense. There are many benefits to this approach, but the main one I'm concerned with here is separation. Notably, the separation between the tooling code and its produced result. Let me explain by going over the character editor, finally. I feel like LLM generated UIs all have this certain distinct look. I have an approximate knowledge of UX best practices core. Anyway, the look and feel don't really bother me. I'm trying to get the job done with this. How does it do? Well, it allows for editing of character packages in a visual way, which, without having to directly edit JSON, which these are huge. These end up being massive, so you don't want to do that. It is clunky as hell, but I'd say it ticks enough of the gets the job done boxes to kind of have sped up my workflow quite a bit here. And the benefit of the separation is that the AI is able to keep its own fugly ass code contained to this huge fuck off script and some weird enums and some glue code that I don't really like either, but at least it's kind of separated from the code that I care about, which I really appreciate. To put it more visually, my approach here was to determine a data model for the character packages, and then the LLM vibed up a whole pile of garbage character editor and a JSON translation layer that I can use to maintain the character data itself. And whenever I needed a new field added to the character data or a new method of interacting with the data, I would just have it get its crap together and make it work. We're definitely, towards the end of this project, I was running into the edge of its capabilities. I think its giant, awful character editor script got a little bit too unwieldy even for the AI to manage. But, on the other hand, this is a pretty complex tool to have built. So in other genres, maybe less complex tooling could be pretty easily done by an LLM. Just saying, it might be something to chase down. Anyway, now that we've covered all that, I was able to use that character editor to author some data and put the actual game engine through its paces while I was developing it. Let's go over one more time, high level, step by step of, say, a jab animation. First, the player is standing still, not pressing anything, idle. Next, the light button is pressed. This goes into an input buffer, storing between frame inputs. This buffer gets stored in the previous frame character buffer for use in the current frame. During a tick, the list of available animations, which is filtered down from cancel windows and the current character state, is consulted and compared against the recent input history. The highest priority match between the inputs and the actual animation input is chosen next to be executed. In this case, it's standing light. Now, if we advance one more frame forward, we've started the animation. Now, no matter what the player presses, outside of some very specific situations, they're currently locked into this jab animation. This is the committal animation style that we were talking about before. The startup frames come first, and then the active frames. The active frames have hitboxes, which may or may not collide with the opponent's hurt boxes. And when this happens here, either block stun or hit stun paths are triggered in the collision manager. Basically, some calculations happen. A hit stun number and a hit stop number are generated. The hit stop plays out first, which is what the screen freeze is and the screen shake is tied to. And then after the hit stop, both characters continue animating, with the defending character going through its hit stun depending on the number of, the configurable number of hit stun frames that the attack generates, and then eventually recovering out to idle. Of course, the attacking player goes through the rest of its active frames, if any, into recovery frames, and then eventually recovering back out into idle itself. And thinking about this from a frame-by-frame perspective, a fun aside on fighting games specifically, the character that enters the actionable state first, here shown by the grayed out boxes, is at advantage, or to put it another way, they're +3. Anyway, what did we learn with this rep? Although we didn't finish our fighting game, these animations would have taken forever. I knew this. I was ready for it. I'm ready for slow burning on these animations for the rest of my life. This is actually the furthest I've gotten on a fighting game, structure-wise. And overall, I think a pretty good experience. I think one of my biggest takeaways from this project is partially finishing a large project can be just as useful as finishing a small project in a lot of ways. I mean, obviously, there's lots of positives to actually finishing things and shipping them and learning how that process goes. But there's also lots of benefits to biting off more than you can chew and being confronted with big problems that you have to get around. I think another takeaway for me was keeping AI out of the code you actually want to maintain can help grant some of the benefits without most of the drawbacks. Don't ask me about the 3 or 4 projects that I didn't post about in between Frankie Forehands and today. I might have made that mistake a few times. Barf. I'm actually not that bad at sprite work, surprisingly. I don't know, I think this guy looks great. And Burnout and Depression suck ass, but that's not directly related. Anyways, I'll be back for more reps. Peace.